Then we move on to feature selection, and feature selection is equal to correlation analysis. So correlation with target is equal to PD dot data frame brackets and correlation with target brackets features with X dot columns. The correlation with targets brackets correlation equal to brackets X brackets column for correlation with Y for col and X columns. So basically this chunk of code, it creates like a structured data frame to store like and organize like the correlation values between like each of the features and like the diabetes target variable. This helps us identify like which health measurements have like the strongest like relationship with like diabetes. So yeah. Next, we move on to our correlation with target brackets absolute correlation is equal to correlation with target brackets correlation absolute, and correlation with target is equal to correlation with target dot sort values brackets absolute correlation ascending is equal to false. Basically, what this line of code does, it basically sorts the correlation by absolute variable, sorts them in a descending order. And then here we display the correlation target with like the first 10. So here we have the correlation with the target variable of diabetes. So the first one, which has the highest correlation, is like blood glucose level feature with a correlation of like 0.41 and an absolute correlation of 0.41. And then this goes down all the way down to like smoking never, which has a correlation of 0.027 and an absolute correlation of 0.027. Next, we move on to plt.figure fixed size equal to 10 to 6, all the way down to plt.height layout. Basically, this visualizes the top 10 correlation. So in this graph, we have the top 10 features by correlation with diabetes. As told before, the highest correlation coefficient is like blood glucose level, followed up by HbA1c levels, all the way down to like the lowest one, which is in this case would be like smoking history, no information, and then followed up by like smoking history never. So yeah. Next we move on to creating like a correlation heat map for the key numerical features. So we basically do plt.figure fixed size equal to 10, 8. Basically this creates like a new figure with like 10 inches width and 8 inches high. Key features equal to numerical features plus gender and diabetes. Basically this creates like a list of features to include in the correlation analysis. Correlation matrix is equal to df process brackets key features dot correlation. Basically this calculates the correlation matrix for like the selected features. And then we have sns.heatmap with these parameters. Basically, this visualizes the correlation matrix as like a colored coded heat map over here. And then we title it and then we plot it. So as we can see from this chart over here, that the redder the color, it has like a higher correlation as compared to like the bluer the color. So for example, something as blood glucose level has like a higher correlation with diabetes as compared to something like such as gender with diabetes. So yeah. Next we move on to calculating variance for each of the features. So variance feature variance is equal to pd.data frame brackets. Basically this creates like an empty data frame to store the results. Then we have features variance brackets features equal to x.columns. Basically this creates like a column named features, and that contains the name of like all the features and like in the data set. Features variance is equal to variance equal to brackets x brackets column dot variance for column and x dot column brackets. Basically this uses like a list comprehension to calculate the variance in each column in the data set. And then we move on to feature variance is equal to feature variance dot sort values variance brackets ascending is equal to false. Basically this sorts the data frame in like a descending order of like variance, so the features with like the highest variance appear at the top, and then we display this. So as we can tell, so the variance for each feature, the top one is like blood glucose level with like a variance of like 1657, all the way down to like heart disease, which has like a variance of like 0.03. So yeah. Then afterwards we visualize the feature variance as seen over here. As told before, blood glucose level has like the highest variance, other than decreasing all the way down to here. So yeah. Then we move on to importing from sklearn feature selection import select kbest, f classifier, and variance threshold. So threshold is equal to 0.01, selector is equal to variance threshold, and x variance selected is equal to selector.fit transform x scaled. So basically what this line code it does, it applies like the variance threshold to remove like low variance features. Then we move on to selected feature variance is equal to x scale.column select brackets selector.get support. Basically, this gets the selected feature names. Then we move on to from print original number of features of x scaled all the way down to like print feature for feature in x scaled columns if feature not in selected feature variants. Basically, what this block of code does, it basically prints the original number of features in the data set, and then it basically prints like how many features remain applying after applying the variance threshold, which basically removes like features with like less than like 0.1 variance as by using like x variance scale dot shape brackets 1, and then it displays the list of selected features that got past the variance threshold, those like variance with like greater than 0.1, showing us which features had like significant variance. Finally prints the list of like removed features, those like with the variance of like less than 0.1%. So the original number of features is 13, the number of features after the variance threshold is like still 13. The selected features are from gender, age, all the way to like smoking history not current, and then here's are the removed features. Next we move on to like basically applying select k-best using like f classifiers. So basically k is equal to 8, selector is equal to select k-best with score function is equal to f classifier, k is equal to k, k-best is equal to selector dot fit transform x scaled and y. Basically this gives us like it says selects like the top 10 features, and then we move on to like unordered select features equal to x scale.columns selector.get support, and then we move on to feature score df equals with the PD data frame with features and score. Basically it creates like a data frame with the features and scores, and then we move on to feature scores data frame is equal to feature score data frame, the scored values scores ascending is equal to false. So basically this gives us like the sorted values descending order. Then we have selected features k-best equal to features scores df.lock. Feature score brackets features is in unordered select features brackets features to list. Then we move on to feature score is equal to pd.data frame. Basically this creates like an MT8 pandas data frame to store like all this statistical information about the features. Then feature scores brackets features equal to xscale.columns. Basically adds a column named feature that contains all the names of all the features from the data set. Feature scores brackets score is equal to selector.scores. Basically this adds a column named score that contains like the f statistical scores calculated by the select k-best algorithm. Then we have feature scores p-values is equal to selector.p-values. Basically this has a column with the p-values associated with each of the f statistics. Then we have feature scores is equal to feature scores dot sort values with these parameters. Basically this sorts the data frame into like a descending order of like the f scores. Then here we print out like the top 8 features selected by the k-best classifier. So here we have the top 8 features. So the first one is like blood level glucose with a score of like 21,000 with a p-value of 0 all the way down to like smoking history former, which has a score of like 968 with like a p-value of 1. And then over here in this block of code we visualize this feature scores as the top. As you can see, these are the top 8 features by the f score. So blood glucose is at 1, and then this goes all the way down to like smoking history former. So yeah. Next we move on to comparing feature selection methods. So top correlation features equal to correlation with target iloc 8 feature brackets features to list. Basically this gives us the top 10 features from the correlation analysis, and comparison equals to pd.data frame with correlation based with this parameters, f statistics based with these parameters, and variance based with these parameters. Basically this compares like the feature selection methods. Then we move on to comparison of features selected by different methods, display comparison. Then we move on to common feature set, top correlation features, and set selected features k-best, and set selected features. Basically this gives us the features that appear in all these methods. And then we have features that selected by all these methods, then we print it out. So these are like the comparison of the features selected by the different methods over here. So these are like all the features for the correlation based, statistic based, and variance based over here. And these are all the features that are selected by all 3 of these models, which are like HB1C levels all the way up to BMI. Then we move on to final features equal to selected features k-best, and print final selected features, print final features. So we're basically using the features selected by select kbest mostly because they identify features that'll have like a statistical significant relationship with like diabetes variable. And it's also ordered by like importance with the modifications we made, as the features are properly ordered by like their F scores, ensuring that we're using like the most predictive feature list. And then afterwards we do x final is equal to x scaled brackets final features. Basically this creates the final feature set. So these are all the final select features from blood glucose level all the way up till smoking history former. So yeah.